Hi, everybody. It's me again, and we're going to talk a little bit about the Renaissance and early astronomers. So, in the first video, in 1.1, we talked a little bit about the very early astronomy. Now we're going to deal more with what started in the 1400s and move on from there to where we are now. The Renaissance was a period in European history from the 1400s to the 1600s. It was marked by cultural, artistic, political, and scientific advancement. Science really took off during the Renaissance. It was a time of enlightenment. It bridged the gap between the Middle Ages and modern times. The Middle Ages, not a lot happened. There were definitely discoveries, but it was definitely slow. Now, this sparked a real rebirth. It was characterized by an attempt to surpass achievements from classical antiquity, to actually get beyond what they knew before and to start moving forward. So many scientific advancements took place during this time, and this is where astronomy gets a really big jump, as do other branches of science. Copernicus is the first one we're going to look at. He's a Polish astronomer and Roman Catholic canon, which is very similar to a priest, not quite a priest, but similar. He proposed heliocentrism. So this had been talked about in the previous video, but now this was actually much more established. They started to realize through measurements and through observations that it looked like the Earth was going around the sun. It wasn't the perfect model, but it did put planets moving in orbits around the sun. He didn't publish his book until just before his death because it was very touchy at the time. He didn't want to go against the Roman Catholic Church because they thought that the Earth was the center of the universe, and they didn't look too highly upon people saying it didn't. Johannes Kepler, 1571 to the early 1630s, or around 1630. He's German-born. So he was born to poor parents, but he became a professor. He determined that planets don't move in circular orbits. They move in something called an ellipse, which is kind of like an oval. And he developed 3 laws of planetary motion that we'll talk about later. He defended the Copernican view that said that heliocentrism was true, that the sun was in the center. And he avoided persecution by the church by writing his wife in code. He actually had to write in code in order to, discuss things with his wife so that they wouldn't figure out what he was talking about. That's how serious they took this. It was called heresy. Galileo, you may have heard of him. He was around in the late 1500s and early 1600s. He was Italian-born. He vastly improved upon telescopes. So telescopes weren't his invention, but he made them better. And through his use with telescopes, he discovered 4 moons of Jupiter called the Galilean moons. He also discovered that gravity affects all falling objects the same. Sometimes they talk about him dropping things off of the Leaning Tower of Pisa and how they fall through the air at the same rate. He designed the first pendulum clock, and he supported the Copernican system and was found guilty of heresy. Now, he got in trouble from the church, and he had to spend time under house arrest because he supported the idea that the sun was in the middle and the planets were all going around the sun, and it wasn't the Earth in the middle. Christian Huygens would have come around, towards the end of Galileo's life. Huygens was born to a wealthy family in the Netherlands. You can kind of tell based on that very pretty wig he's wearing. He proposed the first theory of light, which is wave theory, which is something we still discuss today. He improved upon the telescope, and he discovered that Saturn had rings. They didn't know what was going on with Saturn when they first saw it. It looked like it had a bulge in the middle, and he found that they were actually rings going around. He discovered Saturn's largest moon, Titan. Titan actually means, large. And he made the first known drawing of the Orion Nebula. We see the Orion Nebula, and we see Orion quite often up here in the Northern Hemisphere. We'll talk about that later in the class. And the Huygens probe landed on Titan. They named the probe that landed on that moon after him because he was the one who discovered it. Newton, another name you've probably heard. He was also born to poor farmers. He didn't grow up with a lot of money. He's known for the 3 laws of motion that you probably studied in 9th grade, Newton's laws. He's also known for his work on gravity. There's something called the universal law of gravitation, and that measures the pull from between objects, between 2 different objects. He used a prism to determine that white light is actually a mixture of the colors, that it spreads into all the colors of the rainbow when it goes through a prism. He invented the reflecting telescope. That's a different type of telescope as opposed to refracting. It's a different design. He's credited for the invention of calculus. So for any of you who really love your math, calculus was credited to Newton. There's a unit of force named after him called the Newton. He was knighted by Queen Anne, so he's actually Sir Isaac Newton. That's what it means when you're called Sir. It means you have a knighthood. Now, these people we're just going to fly through. There's not a ton to talk about with them, but there are some famous names that you might have heard of or that might pop up. One is Edmund Halley. Edmund Halley is known for proposing a particular comet viewed at regular intervals was the same comet. And he was correct. And of course, that comet is Halley's Comet. It comes around once every about 76 years. And we'll talk more about comets later. Charles Messier. He was around in the late 1700s and early 1800s. He was the first astronomer who published an extensive list of galaxies, stars, and comets. And it's actually a catalog that was created that we still use today. It's the Messier catalog. And it's something that it's Messier is what it looks like. It's Messier because he's French. And it's still used today. This combo, a husband and wife team, William and Caroline Herschel, they both did a lot of work on deep sky objects with a very powerful telescope at the time. And they discovered Uranus, a couple of its moons, or they did work on Uranus and its moons, and they discovered more of Saturn's moons, and they saw that there were ice caps on Mars. She became the first woman ever to discover a comet, and she identified several more. Henrietta Swan Leavitt, she was the late 1800s and early 1900s, worked as a human computer, which means basically she was a mathematician. And she worked doing math at Harvard. She identified variable stars, which we'll talk about later. They're stars that their intensity changes. They get brighter and dimmer over time. And she's credited for discovering what are called Cepheid variables. And that's the variable type of star. And they're very important in identifying distance in space. Then we have Annie Jump Cannon. She classified over 350,000 stars manually, just looking at star charts and looking at pictures and you can see her doing it there. She identified those and cataloged them. And she realized that the star's elements created different wavelengths and determined color. So we could tell that what stars are made out of by the color of their light. She improved star classification with 10 categories by color and brightness. So she was able to help with the classification system for stars. Here we have this guy, who we've probably seen before. He was around in the late 1800s and up through about the mid-1900s. This is Einstein. He suggested laws of physics are universal. The speed of light is constant in a vacuum. Conceived the idea of space-time, which is a big deal. And he penned the theory of relativity, which expands on Newton's work. So he took the idea of gravity and he incorporated that into his theory of relativity. And he's also known for this famous little E equals mc squared thing, where energy is equal to mass times the speed of light squared. All right, couple more. Edwin Hubble, kind of a famous last name. He was around right at the turn of the century, right at the turn of the 19th to the 20th century. He determined that the universe was expanding. And we'll talk about that as we go along here, too, about how we know that that's happening. But the universe is getting bigger. Expansion became known as Hubble's law. He created a standard system of galaxy classification. And the Hubble telescope was named after him, and we still use the Hubble now, although we have the James Webb is the brand new one that just got fired up. Stephen Hawking, he only died a couple years ago, proposed both a beginning and an end of the universe, that it has a beginning and an end, and that it might go in cycles. We don't really know, because the beginning isn't the beginning of all things, it's just the beginning of the end of the universe. He's considered a great mind, but he was wheelchair-bound because he had something called ALS, and he had that since he was 20. Usually people don't live very long with ALS, but he lived for quite a while. He lived for like 50 years with that debilitating disease. He predicted black holes emit radiation, and they call that Hawking radiation, and he wrote many books explaining complicated ideas to non-scientists. And our last two. These two are people whose voices you will probably hear over the course of this class. The first one is Carl Sagan. He died relatively young. He explained the high temperatures on Venus and explained that it was a greenhouse effect causing them. He explained seasonal changes on Mars. And he popularized astronomy with the series called The Cosmos. And his voice is quite memorable to anybody who ever watched that show. He's got a very distinct way of talking. And he really educated the public on on space. And he founded something called the Planetary Society, which is being carried on by the guy underneath, Neil deGrasse Tyson, who is also a very important voice in astronomy. Before he became kind of a teacher of astronomy, he worked on both the galactic bulge, which we'll talk about later, and type 1a supernova, which is a type of star exploding. He's the director of the Hayden Planetarium, which is actually a prestigious position, and host of many science shows, including the reboot of Cosmos. He also did Origins, and he does his own show called Star Talk. He received the Public Welfare Medal for exciting the public in science. So he's quite the teacher. Just a couple things to ponder. After watching this, are there any of the others that you've heard of that maybe could have made the list? There are. It just would have taken too much time. But how well represented are people of color or females in Renaissance astronomy, and why do you think that is? Why is it that we don't see females pop up until later, or people of color pop up until later? It has to do with what Renaissance astronomy was. It took place in Europe.